There we go. We are now live on air, so hopefully people can start to see the presentation that Yevhen's going to provide us later. So please go to the Jabber room for Orleans, or go to Twitter, or go to wherever and post your comments and questions. Yevhen's going to get to them at the end of his presentation, so he's going to work through his presentation slide by slide, and then take all questions at the end. So I shall mute myself and hand over to you. Would you like to introduce yourself and crack on?
Are we starting already?
Yep,
okay.
We're going. Yep.
Okay, so will you be recording the presentation?
Yeah, it's all being recorded. Yep.
Okay, great. So let's start. The presentation is called something very strange. The uniform interface is 42. I prepared it exclusively for the Orleans virtual meetup, and I'd like to start and introduce myself. So let me see this. Okay. So that's about me. If you can decode it, then you know everything about me. Actually started programming 15 years ago, and I did a lot of stuff already in the industry. I was working mostly with the business applications. So if you need to understand my background from where I'm coming from. For the past 5 years, I'm mostly working on the scalable business applications, mostly the software service software, and the in the last 2 years I gravitated toward the distributed applications, and now working at a company called UScan. We're doing a big data analysis. Precisely, we're doing the social media monitoring. So we have, adding a few gigabytes of textual data every day that we need to filter, index, etc., etc. I'd like, before starting the presentation, I just want to apologize because I'm not a native English speaker. So I just want to apologize up front for any, grammar, pronunciation, and tenses misuse and all of that. So please, forgive me if I do it. Now.
Inexcusable. We're all these native speakers, and we cannot tolerate any mistakes.
Yeah, thank you very much. Okay, so the presentation is will be, I just wanted to be a little. I don't want to fall asleep, and I don't want to be boring. So I actually invented. I think that I will be, playing 2 roles during the presentation. One of the will be a role of a newbie developer, and the second there will be a role of the old man. So that should be funny. So let's start, and I just want to. That's how it all started. Jacob said that he wanted to hear my ideas, and they want to talk about the Orleans bus project that I did before, and also some of the Orleans patterns and best practices. And then we have an interesting conversation with the guys on the GitHub when the Orleans was open sourced, and I also pointed out about the importance of having a uniform interface for the Orleans. So Sergey asked me that will be kind of interesting philosophical discussion. So what I have decided is to, how you say in English, kill 2 birds with 1 stone. Instead of having that, philosophical, boring discussion, I'd like to have that completely practical, something that you can, apply immediately to your own projects and have, benefits from that. The thing that I'll be talking about not only applicable to Orleans development, to Orleans-based development, but they are applicable in general to, any software project. So let's start by setting this scene. So imagine that we are dealing with, some e-commerce site, and we have a lot of items in the inventory, and we have sellers that are, actively creating new items, adding the quantities of those items to inventory, deactivating them, and so on. And on the other side, we have buyers who is buying the items and constantly checking out the some quantities of those items from the inventory. And let's imagine that we have everything backed by some ubiquitous Microsoft SQL database, and it seems like that kind of system could really benefit if we implement our items as the actors, so we can have save on all of those wasted cycles of read from a database, update, modify, run some rules, and store again. And also there is a lot of concurrency going on. The buyers are actually competing on the items themselves, and there are some complex business rules such as when the items go low in stock, you need to notify someone, etc., etc. Also, there could be, it will be a simple example, but you should understand that it could be tens of other similar entities that could benefit from being implemented as actors. That could be such things as the orders, invoices, invoice journal, etc., etc. So let's start from the use cases. For sellers, we have the following use cases. They can create an item, they can rename it, deactivate, and they can add some quantity to stock. For buyers, there's the only single use case. They can order an item and actually buy it. They can order some quantity of them. And for both of them, the use case is that to get item details like the name, the quantity in stock, whether it's active, and so on. So if we start with the how we do with inner links, it's really everything starts from the links interface project. We just define the grain, and it could be something as simple as this. You have the interface, and we define the methods one-to-one for the use case, so we can create an item, rename, check in, check out, and deactivate or get the details. So that's pretty much stuff that you understand. And for the implementation part, we'll use the Erlin's declarative persistence. For now, we have the following state for the item grain. It's the name, quantity, and whether it's active or not. So if you are familiar with the Erlin's declarative persistence, that should be very easy to follow here. Now, what I want is to zoom on a particular implementation. Let's start from a create item method. It's pretty self-explanatory. We have some rules, some business rules, like we checking that you can't create an item with an empty name. We also have a check whether the item name is not null. That means that item is already created. So we actually do some validation. Then we simply assign some properties and the write state back to the storage. Same here for deactivate. Some rules, then the state mutation, and then we write it back to storage. And finally, let's see, for example, the checkout method. Checkout method is a bit more involved. You can see there's the some business rules like checking whether the quantity is negative or not, and then we have that particular check that you can't check out more quantity than we have in stock. And again, after everything succeeds, we mutate the state, namely the quantity, and then store it back to storage. And now so far so good, but there is something that bothers the old man. Remember the old man that I actually told you about? So first of all of our methods looks kind of similar. They all have some business logic, and then they store state in storage. Now, what's cool about the thing, actually not cool, is that the old man think that this is actually kind of a duplication. We are actually duplicating behavior. We do, we are repeating the same behavior all over the place, and I think this violation of dry, do not repeat yourself principle. But our newbie developers say, come on, old man, that's not such a big problem. Okay, say the old man, as you wish. Now it's time to write a unit test to make sure that our business logic is, error-free. Let's try to write a unit test. So we'll try to unit test, say, that branch. That should be easy, right? So what we assume here is that the quantity will be initialized to 0 by default. So now we can write a very simple test. We just create an inventory item grain and just invoke the checkout method. So let's run it. Oops, we have an exception. What it is, instead of the read operation exception, we have a null reference exception. Something is definitely wrong. Let's check what exactly is causing this. It looks like we are using the state property, and if you know how the Arlene's declarative persistence actually works, it works like this. First, you define an interface, okay? Then you inherit from some special, grain class, base class that is supported by the framework, and you also specify the storage provider. Decode again, then we'll run, and the proxy implementation for your grain state interface will be created. Then at runtime, finally at runtime, the instance of proxy will be automatically created by the framework and made available to you via the state property. So the key word here is runtime. That means it will be null until you actually run the Scala. Oh, but we can just set the state property, no? You might be thinking that we can simply override the state property within our test, set it to some stub, and end of story. But unfortunately, it is not possible because the state property, first of all, it is protected, and it actually read-only. There is no setter. So how can we deal with it? Well, we just need to spin a real Scala, and then we'll be able to run a test without any troubles, right? So let's do it. No more cheating here. Let's run the test. Say we have set up everything, and now we have a seal running, and we use a real grain factory to get the grain, and then we'll try again to invoke a checkout function. Okay, run the test. Boom, it fails again. But now it's something different. The number is now different, the line number is now different, but the exception in the source is completely unexpected. What's going on? Okay, looks like the offending code is this one. Since we're running with the real Scala and the grain is using Arlene's declarative persistence, upon activation the framework tries to read the grain state using the specified provider, and that fails, since database connection defined in config file is actually pointing to a production environment which is not accessible from a developer's computer. Yeah, so it looked like in order to successfully run this test, we actually need to make the following things to happen. First of all, we need to set up and run test integration Scala in a test harness, which could be a little bit slow. Sometimes it takes few seconds to boot, sometimes it might be 5 to 7 seconds. And the second, we also need to create an empty test database on a local SQL Server instance, and we need to run the migration scripts to set up the DB schema, right? What else? We also need to clean up the database before every test. That is the isolation and repeatability of the test. To test a single line of a domain code, that simple line, we literally need to cross the river. I believe it's something, something really wrong. So what we have here, the options are, we can use, only the full-blown integration testing, like set up and run Scala, set up all of the dependencies, set up the environment, etc., which simply means, yeah, it's painful. And the second option is, don't write unit tests at all, just discard it, which simply means we have give up. So no wonder, well, with all that complexity that people, label unit testing as slow, it is hard. It doesn't worth the price. You should not fight the framework. Just write an integration test. What it means actually, literally, is just accept the pain. And now the old man enters the room and says, stop. Really? Stop, think about why are you having all of these issues at the first place. Yeah, the framework is a bit inconvenient for unit testing, no doubts, but it's not the actual problem here. The actual problem is this, and it's all about this. Basically, we are violating the separation of concerns. Now, if we get back to our sample code, we can clearly see the violation of separation of concerns here. What is happening is that we are mixing different levels of abstraction within a single method. You see, this is the high-level domain logic is mixed with, you know, a low-level persistence-threaded code, which is basically an infrastructure part. That is the root cause of all troubles. It's not the framework, it's a design issue. Even if you substitute Orion's persistence to your own one, the issue will stay. With your own persistence approach, you will still need to checkpoint the state after every operation. It is not allowed to lose state here, so timer won't help you as well. So old man, tell us, how can we fix this? Oh, no problem, said the old man. You just need to split them, right? Separate the concerns. So what is happening here is that we are actually splitting the grain into two entities. The first one, you know, that framework dependent, hard to test, you know, grain class, which simply delegates everything to, you know, easy to test and independent infrastructure, independent plain old C# object on the right. So far so good, right? What we can do here is that, if you can, as you can see, the Poker class actually accepting the state as the constructor parameter, and since we are doing that since we are creating it on activate async, the state is already available. And now, what does it mean? That we can use to test that our business logic. We can simply use the Poker class in our unit test, right, and pass, you know, simple stop to state and be done. Okay, so that's just, you know, simple delegation to Poker. There is no persistence. You just state in the main logic. So it all actually boils down to a simple rule. If something is hard to test, at least make it so trivial so that making an investment in automated testing of the thing make no sense. Now let's see how the unit test will look like. Okay, we're creating a stub for the inventory item state, and then we initialize in the Poker, and then we invoke the operation. Let's run it. Wow, cool. We know the test actually passed it, and as you can see, writing was really a breeze, and it was also insanely fast test. We can run thousands of such tests in a matter of seconds and test all of our, you know, important business logic. And as you understand, in a, you know, commerce application, that could be really an issue if you have errors. You know, some financial, you know, some financial bugs are really important to fight them. So, but there is something that bothers the old man. Well, I see the duplication all over the place. First of all, we have the interface declaration. Second, we have a grain implementation class declaration with all the same method signatures. And third, we have a Poker with exactly the same method signatures repeated again. We repeat the same declaration 3 times per every method, including the delegation. It's actually 4 times for every method. I don't think that this is a dry. So, what to do? Old man, you have promised us pineapples, but this is all lemons. Yeah, you're right. How can I get rid of duplication here? Tell us how to eliminate it, what we are doing wrong. And the old man said, you know, it's all because you have a non-uniform interface. An old man, you keep using this word uniform. Could you please be more specific and finally show us what this is all about? Sure, said the old man, let me show you that, you know, starting from something very, very simple, like making the delegation from grain to Poker generic, will then build up, you know, to move to uniform interface by step. So let's start. What we want to do is to make that delegation from grain to Poker being really generic and get rid of the duplication here. Can we make it with the current code? I don't think so. The problem is simple. We are dealing with non-uniform interface. What does it mean to have a non-uniform interface? First of all, that means that the names of of the methods vary. And the second one is also dealing with the variable method signatures. As you can see here, the checkout accept a single int parameter and deactivate accept no parameters at all. So what could be a solution here? And the solution is pretty much simple. Let's start from the variable signatures. Solution is to introduce parameter object, which is pretty much simple refactoring that you can find in the Martin Fowler book. So how it will look like with that, what we do is we actually, for each method, we create the parameter object that holds the original parameters of the method. So it looks like this. And now our delegation code start looking like this. Can we make it generic? Well, I'm still unable to make it generic, and this is because we have a variable method names. We need to make them generic as well. So what is solution? A solution is simple. We have the overloads in C#, and we can have an overload of method based on a parameter type. That's not a problem. So let's just rename all methods, and they all now look all the same. You see, all the methods are called handle. Let's call them the handle list. That's a nice name. Now, what we have here is all of our delegation dispatch method looks exactly the same. I believe now we can make it generic, but how? One way is to just use the reflection and something like that. But there is no point doing that. In C# we have a dynamic keyword, and you can make a dynamic dispatch pretty easily. So as you can see now, we have a completely generic way to dispatch something to Poca. So isn't it nice? Nice. I believe dynamic dispatch is very easy, but it's just a start, right? So what we have here, the problem that we still have a lot of duplication, and it all comes from converting from a non-uniform interface to uniform. Honestly, it looks silly, right? It's just a waste of time, energy, and resources. The problem is, while we made the Poca interface uniform, the grain interface is still non-uniform. But what if we make it uniform as well? Can we do it? So this was our original interface. It looks like this. We have some methods, all the Arlins requires that they all return task, so that's okay. How can we make it a generic one? Well, pretty easily. We just we just delete all of that specific methods and create one single method. Let's call it receive. I like the name, which simply takes the single parameter, exactly as all of our Poca grain methods now. So how it will look on the implementation part? Before it was looking like this, and now implementing the uniform grain interface, it will look like this. So basically our handle generic dispatch method is now just implementing the receive method from the base interface. Well, it's actually it's just one method, and it looks really simple, and we got rid of a duplication. We now have, instead of 3 methods, we now have a single one that is doing all of the work. And you see how nicely we got rid of a duplication for the state checkpoint. It's now isolated to a single place. Well, that's nice. But in order to send the args data structures, we need to make one more change. First of all, we need to move this args classes to interface project. And we also need to put the serializable attribute so that the Arlins code again can generate the optimized serialization code for those structures. Also, I believe that we can drop the args prefix. It's just kind of a noise. I don't like noise. So that will change the interface of our Poca to just this. Okay, and also let's rename the args parameter to say something like message. I really like, just for the kicks. Now, interesting how all of that has changed our client code. So it was something like this: await, grain, checkout, simple method call, and now it looks like this. Well, a little bit more verbose, but still tolerable, as for me. So the interesting thing is that we can think, why do we need the poker now? Say the old man. It looks like we can simply merge the methods back to a grain and leave them public. So that will allow us to use them in a unit test, avoiding the need to go via that hard to test receive function. So looks like a plan. Let's try. That is our final grain class. We just get rid of the poker, and what's interesting is that change make our grain kind of a multi-part. First of all, that a receive function will be called only at runtime, and it will, everything should work, exactly as it should. State will be checkpointed, the state property will be set at that point, all is good. While the our handle methods could be, easily call it from the unit test, and we can just directly invoke them. And since they have no dependencies on the hard to test state property that requires spinning up the silo, it should be really simple to test. So let's see how a unit test now looks like. Okay, we are back again to just creating the instance of inventory item, and then instead of going through receive, we just directly call the appropriate handle method. So let's run it. Whoa, we forgot about another reason why we have created the poker, the state property, which is initialized only when running inside the silo. Are we back to square root of 1? Can we fix that somehow? You see that our handle methods all actually call back to a state property, which is, just initialized by the earlings at runtime. Something bothers me here, so let's see the big picture. It looks like all of our handle methods are dependent on state property, same as our receive function, so it looks like we can't fix it at all and need to revert back to a poker approach. Interesting. If you look more closely, it looks like the handle methods and receive function depend on a completely different parts of the state interface, while handle methods exclusively use only getters and setters of custom data properties, but receive function on opposite is using exclusively only the checkpointing function. Why is that? Yeah, it's always this. Actually, it's this. The issue that we have now is that the iGrain state is also mixing the levels of abstraction. It is both the bag of custom properties and it also unit of work. Well, okay, it's something that was already discussed on Codaplex forum, so nothing new here. But is it such a big problem? Does the framework is guilty again? I don't think so. Well, look again. What if we make all of our handle methods independent of state property and instead just create and use local fields as if it were a normal object? That should work, but how then this data would be passed to an underlying storage provider? Previously it was passed along the state object. Well, it looks like our receive uber function is rescued us again. It's actually a good place to set the data on the state property before checkpointing to storage provider. Since each, in every operation go through this function, that is actually a really good place. What we did now is that we have isolated all of the hard to test code within a single trivial function. That's nice. I like it. So at this point, you might question why using declarative persistence at all if you can have more optimal solution by creating and injecting custom storage provider. That's a different story. My point was to show that it's not a framework which is bad or inconvenient, but raise a design issue. Okay, so let's recap. What do we have here? I believe we have arrived at something big without even realizing it. So what we ended up with is the grain interface implementation with the single method, the bunch of data structures, one for every operation, and the grain implementation function with that, Uber function, which is doing dynamic dispatch for us. So, that style of the architecture is colloquially known as message passing. So if you look in the Wikipedia about the message passing, we can find the following description. In computer science, message passing is a message to a process, which may be an actor, wow, coincidence, object, and relies on the process and the supporting infrastructure to select and invoke the actual code to run. Well, interesting definition, looks like exactly what we have here. So this bunch of data structures are actually called messages, and their tuber function that is doing dynamic dispatch is called the selector or dispatcher, simply. An interesting property is that the another name for that Uber function, it is a higher order function. It is also known, more functional style for development. So if you actually if you are accustomed with the languages such as F# or any functional language, then that term should be really known to you. So that was first part of the presentation, practical step-by-step things, and now we are close to the meat. So what I want to say that the messages in higher order functions is really, something really big. By the way, if you try to evaluate this expression, it should compute to something like this. So let's start one by one. First, we start from the messages. The first definition that I want to tell you about is the set of messages that a server, or grain for that matter, can process defines its public interface. What does it mean? Is that that's the all interface declaration we should ever have. Simply because all of the operations that the server can do for us are actually defined as messages. The name of the message defines the intent, and the public fields or properties define the arguments of the operation. Basically, what we have here is we have a separation of intent from the execution. In the normal RPC way of declaring the declaring interfaces, the intent and execution is the same. You invoke the intent. You invoke the intent along with the executing it. You can't have it separate. Here we have a full separation of the intent from the execution, which is nice. The second interesting point that the message is actually a schema. So that should be familiar to you, right? On the left, you see the Microsoft bound declaration of the structures. On the right, you have the Microsoft.NET representation of the same structures. You actually can generate one from the another. So it simply boils down to converting from one representation format to another. It's no problem to just hook up the generator, code generator from Microsoft Bound, and it will happily generate the same declarations that we have on the right. And now, everything is pretty simple. Just hooking the serializer into a Linux pipeline, you can have serialization of Microsoft Bound for free. So another interesting thing is that we now create a custom protocol, something like HTTP, very easily, because HTTP is also the uniform interface, or to be precise, is REST for that matter. So it's not a problem to create the one. We just map, the URL to a type, to ID of the actor, and the operation, and then the body will be the actual payload of the message. So it's not a problem to create something that will deserialize that, just some kind of embedded web server that will be running embedded mode in our Linux cluster and accepting the JSON sent from the HTTP and then converting it back and invoking the interface, because it's pretty simple. The interface is known up front. It's a single method. We only need to create a message by deserializing JSON, which is simple. So the second, let's talk about higher order functions. What's so interesting of the higher order functions is that they actually give us the AOP for free. As you can see, we have a single entry point. Actually, I believe that's the most important hook that any communication framework can provide for us, because it allows us to tap into a communication pipeline. Each and every message will go through this method, through this function. So we can, add any pre or post behavior and do whatever we want. It's pretty simple. If you want to log, if for example we want to log each incoming message, we can just put that command code here. If you, for example, want to log and sample, we can just create two functions where one function is calling another one, basically creating some kind of a pipeline. If you are familiar with ASP.NET, it's actually the same. It's no coincidence because both the ASP.NET and the Orleans have the same model, which is request response. So that was mostly it, and probably running to the end. Yeah, that's the end. So I want to apologize for the quality of the past 10 slides because I was in a hurry making it, and but I think you actually get it, and I hope that you learned a trick or two during the presentation. So now we have 20 minutes, and if you have any questions, I'm all yours. Thank you.
Thank you, Yevhen. That's really good, and I learned a lot there, and it was very enjoyable. I know some questions came up in the chat from the guys in the room, so perhaps you could ask your questions in turn. Am I muted, John?
Wait a sec.
Helps if I put the microphone in front of my mouth.
Hello.
Thanks. Hello, Yevhen. Can you hear me?
Yeah.
Thank you. That was a really good presentation, and I very much enjoyed it and learnt a lot, and definitely some things to think about there.
Yeah.
I know there are some questions that came up in the chat while you were talking, so I wonder if John and Sergey want to ask them in turn, and then you can answer them.
Go on.
Okay, I'll go. Hi, Yevhen. Thanks very much for that talk. It sounds very, very interesting. It's I think we can take it, to a couple stages further, and I'm looking at ways of doing that with F# at the moment. So this thing is actually very similar to the kind of stuff that we were talking about ourselves. So I'm very glad that you formalized it in some sense. One of the problems I've had with dynamic is testing the dynamic dispatch because, as you know, the whole point of dynamic dispatch is to do this thing at runtime. And if you're unit testing the dynamic dispatch piece, then you're going to have a heck of a job trying to figure out whether the message was actually handled correctly. And that's one issue. I mean, in F# we kind of finagle that by using discriminated union, which gives us the ability to tell at compile time that we haven't got a handler for that particular message or whatever it is. I'll also steal Sergey's thunder and ask about the return types. So
answering your question, not sure whether it was a question. I completely agree with you. The message dispatch in F# is much nicer due to the pattern matching and the discriminated unions. It's more safe, and it won't give you a chance to forget about some of the message handler, etc. But if you go back to a C# version, I actually isolated dispatch, dynamic dispatch, down to our Higherorder function, which is the receive. If you want to unit test, you don't want to unit test it via receive function. You just call the actual handler, and it's not going through the dynamic dispatch. So.
No, but I think part of it is actually to make sure that the dynamic dispatch is working correctly, right? So you want to be able to make an assertion that a grain is capable of handling a particular message, and that somewhere along the line somebody comes and changes the semantics of the grain and tries a slightly different version of the, say, the argument, for example, at which point the compiler won't really give you much help to do anything. So unit testing the business logic, I can understand what you're doing. That's perfect for it. But you can't actually say that the whole thing is tested until you make sure that all the messages that you're really expecting are actually tested correctly, right?
Yeah, there are two things here. First of all, you can add a new kind of message, but forget to add a handler for it, right? That could be possible, but I'm not sure how and what you will gain from that. And the second option is that you actually, you created a new type of message and you created a handler, but probably you just, mistyped something and now it's taken a different type of message instead of the one that you've added. That's possible. If you have no unit test, then you definitely have a problems at runtime. The dynamic dispatch is not the only option here as well. For example, we created a proof of concept library to make all of that much simpler. And there we don't use dynamic dispatch. We actually have implemented a static bind, and it's able to tell you that there is no handler for the particular message. Again, it's not as strongly typed. You don't have a compiler support for that, but at least when you try to run a silo, and I believe you should have a QA team anyway, at least do a smoke test of your system. It's not like you just created a message and then go to production and then forget about it. So that's usually that. It actually do not deny that we need to have some kind of integration testing anyway, and the QA need to be involved.
Sure. I guess the more important question is, what do you do with the return type? Because if you now have a uniform interface on the way, then making sure that it looks to me that the only uniform return response that you have is state.write state async, right?
Yeah.
So
okay.
what happens if I want to actually?
I understand. For the samples, I actually omitted the second declaration. I usually create two declarations. So it's still uniform, but I have two methods. The one receive that is not returning anything, just a task, and the second receive, which returns a task of object. You can't see the what we actually do. Then we create an application-specific metadata. For example, I usually create two base classes, such as the comment and query, and I create a query as a generic of T, okay? And when I create a specific class, say the get inventory item details, which is of type query, I actually put that return type into a generic. So I close the generic with the return type. And what you end up with is that when you're looking at the message definition, you can see the return type, what will be returned. And also, when you you can have the same generic version of the receive function, and that will be nicely closed. So when you say something like receive new getting into item details, the return type will be automatically set to the one that you have specified when you were defining the message. So it could be done, and I have the sample for that. If you're interested, I can send you that later.
Hi, Yevhen.
Oh yeah, thank you very much. That would be fantastic, actually. Thank you.
Yeah, no problem.
And very, very good ideas. I really appreciate you taking the time to put something together. And I must compliment you on a very engaging way of writing the slides. So don't sell yourself short. Your English is just fine.
Yeah, thank you very much.
Thanks, Yevhen. I had a question. I just wondered, out of curiosity, how far you'd got implementing this approach, and whether you'd managed to get the HTTP endpoint all connected up, because that started to get really interesting there, I think.
I know that you actually asked this question because you're actually the one who's playing with Node.js, and interoperability is something you're probably interested, right?
Yeah, that's right.
Okay, so we actually got really far. We started with the simple proof of concept library for doing all of that, and it was working. We actually managed to get rid of all of the code generation, so we don't need to generate anything. You don't need to create any interfaces. You just define the messages. You you plug your custom serializer, and that's basically it. We also have the F# API working, and everything is good. You can use discriminated unions and in F#. We have lifted the task builder from the F# CoreX library, and it's actually everything good. We haven't managed to add the HTTP part, but it should be really simple. I've seen there is the CDAR command handling library on the GitHub, which is doing something similar. So the only thing we need to do is to map from the deserializing actually invoke the grain. I think it's half day you can edit yourself. It should be very easy to do. So we have already a sample on how you can plug the JSON serializer. So it's not only a matter of spinning up the Yevhen Katana server, and that's it.
I look forward to seeing the GitHub repo when you've got it all running.
Oh yeah, sure. Next week I'll actually be thinking to talk with you about adding it to Erlin's contrib next week.
That would be great. Yeah, I'd love to see it there. Are there any other questions for Yevhen?
Yeah. Anyone else?
So first of all, thanks a lot. This was great. You mentioned unified interface. I kept thinking, like, what does he mean? It's great presentation. He walked through the whole narrative and steps and showed. Excellent. So slides are great, actually. I don't know why you're concerned about that. So a couple of questions I have. Yeah. So one, so with this dynamic, it seems very similar to what we do with dynamically generated invokers, or invoker classes. They're statically linked for specific classes. We could leverage something similar there?
Yeah.
Force type safety on the invocation side?
Okay, Sergey actually ran out of spare time, and I was not able to put the last slide on my talk. And the last slide was something about, if all of that looks weird to you, just think about what your favorite actor framework is doing behind the scenes, because in a nutshell, you're doing exactly the same, right? There is the message. You can't put the method call in a queue, but you can put the message. So what Erdins is doing when I'm calling something on the interface, it just records the call, record the method name and pack all of the arguments into a message, and then send it to Sila and put it in queue. Then it just get it from queue, unpack the arguments, and dispatch to appropriate method. Am I right?
Yeah, exactly. So
yeah, there is no other way around, right?
Yeah.
So what we get with that Higherorder functions and all of and that a communication pipeline hooking messages, we just made everything explicit. So
right. So I was wondering if it's possible to leverage static invokers on the invocation side, but similarly, with regards to return values, is it possible to have some kind of very simple facade that would do more strongly type casting back at return values?
Yeah, I think so. Yeah, I think so. You can actually create something like, I don't know, you can define an interface, and it might, declare some of that generic marker interface, something like iHandles and T, where the T is the message, and then you can use that and some kind of a helper object, and that will make visible all of the messages that you can send to an actor on the client, and that will make it more strongly typed as well.
Yeah, I cannot say if it will work. Just some initial thoughts. That's something to.
Yeah, on the invocation side, it's definitely possible to get rid of a dynamic. It's very easy. You just kind of scan the actor class on a startup, and now you know that you can automatically create say lambda expressions and compile them for every method that takes a single argument and return a task. So that's exactly what we did in our project, and it's nice. So if you don't need that Higherorder function, you don't need to do anything special. You just define the method that takes the single argument and returns a task, and it will automatically be bound by the runtime.
Yeah, excellent.
Yeah, but on client side, yeah, that something that could be done for sure.
Yes. So just last comment. My initial reaction is it seems like very complementary to kind of the RPC style we have, because we've been dealing with this kind of two broad categories of developers. Kind of more advanced ones that are completely comfortable with messaging, and it's kind of like Erlang style.
Yeah,
scared by that. So
exactly. if you have a look, I don't know, have you seen the Yaka API before? The Yaka is doing exactly the same. They don't use RPC interfaces at all. They use message passing. So that's the kind of a standard API in Yaka. Same for the Erlang. It's also the same in Erlang, the message passing version. So I actually believe that they're really complementary. There is no problem, we have created the project and it was built completely on top of the Orleans and it implements everything, have that alternative API, so there are no breaking changes, nothing like that. It's just an additional API with a more functional feel. Yeah, it is. So
yeah, I like it.
One, the native Orleans API, the method-based one, probably it looks very appealing to to newbie developers because it looks similar. It tried to mimic and create an illusion of like you're just invoking the object and distributed object, while that message-based API it makes things explicit. Like you see that it's not you're not calling an object, you're sending a message to an object. And it actually enables it enables the composition around that. It's really easy to do a composition around the method with the single parameter. You can just decorate it infinitely, both on the client side and on the server side. It's easy. So it's more for advanced scenarios. If you want to create something more complex and you want to get rid of a duplication, it allows reuse. It makes the code more dry. There is no duplication, etc.
Yeah, it looks like
lot of interesting properties with the message passing.
Hi, Evgeny.
Yeah, hi.
With Sergey in the same conference room. Yeah, thanks a lot for the presentation. Very, very good way to present it. I had one question. On the last slide, the separation of concerns, like separating the application code from the framework code.
Mm-hmm.
And I think this is a great point. But I think it's not easy. Like your example was that the wrapper code does the read state, calls the business logic, and then calls write state. So that works great, but in some application. But there is other business logic that, for example, let's say sometimes, based on the business logic, you do not need to do the write state because you decide nothing really changed that I need to write. Or sometimes within the business logic, you want to do, I need to write it. If I succeeded, I mean, this is distributed system. You cannot really hide it all, right? So if it succeeds, if the write to search succeeds, you do X. If it fails, you do Y. If they want to try. There are complex interactions between the business logic and the framework. And this is a holy grail, I think, of any complex systems to hide all the interactions with the framework. Is it possible? How would you really fully hide it?
Yeah, I can tell. First of all, I believe we need to to distinguish between different types of the actors. The one that I was presenting was, I call them entity actor. The entity actor is, something very simple. It doesn't interact with any other actors. Like, it only holds the business logic, then it caches the state that is that business logic is, working. It's just the mutation around that state, and it all sits in memory and allows you to save those precise cycles and not go into expensive storage and all of that. And we can talk about the other kinds of actors that are interacting with the other actors. I call those the process managers, and the process managers are a little bit different beasts, but still could be tackled. About the issue that about the state and all the complex interaction with the storage, I understand. For example, in my sample, it was like this: the message comes in, we execute some business logic, it mutates state, and then we try to state to checkpoint it in some generic way inside of the receive function. And if it fails, what we'll do? We now have a corrupted state. So we have inconsistency between in-memory state, in state and storage. So that's, different tactics could be applied here. I'm a big fan of the CQRS and event sourcing in general, and with event sourcing, it could be very, very simple. What does it mean is that all of your business logic methods, they are not directly mutating the state, so the side effects that they produce, they only computed but not applied at the moment. So what is happening when the request comes in, you compute the you have your guards that hold your invariants, and they say, oh, it's okay to proceed to a next state transition. So you compute the side effect as an event, and you return it back to that generic function. Then it tries to store it, to storage, and if it succeeds, it then applies it back, and the state is actually mutated. So in this way, there is no state corruption, and it's very simple. Without the event sourcing, that's not that simple, and you probably can make some support. Again, that high order function could be used. You can use the same similar approach that we have in declarative persistence, like the generic state object that you can say snapshot before the operation and then restore if something goes wrong. Something like this. Hello?
We're still here, don't worry.
Okay, just lost.
We've about reached the.
This will solve the problem of like a divergence of the local state with the remote state. It's a great approach. I still wonder, like, if, as I said, if let's say you want to write only some special parts of the state, or you want, based on the result of the checkpoint, you want to execute different logic in the business logic. If you if you to checkpoint you do X, if you didn't you do Y. Like complex interactions.
I haven't experienced it. I have no experience with such actors before. So if you send me a sample, maybe we can try the way, find a way if that's possible or not. That is possible. That it's not. There is no way to do it in a generic fashion. That's possible. So it's maybe not for all types.
There are different actors, and for some actors. Some certain types of actors, like entities, this is a much simpler approach versus, well, other actors that have more complex interactions. They may need to do something.
Yeah. For example, the process manager actors could be really complex beasts. They can, execute something on timer. They can use reminders. Then they can interact with the other grains. They can interact with the, third-party dependencies, can storage, just execute some HTTP calls. So that's complex beasts, and for some, if there is really complex logic inside of them, and the interactions are trivial, like you just invoke something on the web, maybe you can create a more high-level abstraction and then just use the mock using your unit tests. That's another possible approach.
Yep. Excellent.
Okay.
Well, great, thank you, Yevhen. I think we've about run out of time. I'm sure Yevhen will pick up any additional questions on Twitter or in forums or wherever. So
yeah, sure.
But thank you very much. Very good presentation, very good slides, and some really interesting things to think about. So hopefully we'll meet again in about a month. If anyone has a talk they'd like to present, please let me know, and we'll arrange that. I think Ruben had some ideas, so I might try and tap him up. But it'd be good to get a few things lined up. So please let me know. And thanks again. This will be available on YouTube shortly afterwards. So for those who've missed it or missed the start, should be able to catch that then. Thank you, guys. Cheerio. And thanks again, Yevhen.
Thank you. That was great.
Yeah. Thanks a lot.
Bye.
Yeah, thank you, guys. Bye-bye.
Bye.